We now know the filter shapes: low pass, high pass, band reject, and the Butterworth idea. The next question is practical. Given a specification, how do we turn it into active stages that can actually be built? A filter design starts with a specification box. First, identify the shape. Then, mark the pass band, stop band, and transition region. Add the required gain, the source resistance, the load, and any limit on ripple or attenuation. Without this box, the circuit is just a guess. The frequency targets come next. For a simple edge, name the cutoff frequency. For a middle band filter, name the lower edge, upper edge, center frequency, bandwidth, and Q. Keep the units consistent: hertz for measurement, angular frequency for formulas, and log frequency for both plots. Order controls how aggressively the filter separates passband from stopband. First order is gentle, second order is sharper. Fourth order can be split into two second-order sections. The higher the order, the more stages and the more sensitivity you must manage. A large active filter is usually not one giant circuit. It is a cascade of smaller sections. Each section handles one pair of poles or one simple edge. This makes the design easier to tune, easier to simulate, and easier to debug. After the order is known, choose a topology. Sallen-Key is common for voltage mode second-order sections. Multiple feedback forms are useful when an inverting structure or tighter bandpass behavior is wanted. The topology is not the goal. It is the physical way to realize the chosen response. Do not place all gain in the most sensitive section unless you have a reason. Distribute gain so the op-amp has headroom, the signal does not clip, and noise is not amplified too early. A clean block diagram often prevents a messy circuit. Component scaling is the practical arithmetic step. Choose convenient capacitor values, then compute resistor values. After that, round to real component series values and check how far the cutoff or center frequency moved. Good design is not just solving a formula, it is landing on parts you can buy. Loading can quietly change the filter. The source can load the first stage, one stage can load the next, and the output load can change the final response. Buffers and active stages reduce this interaction, but every op-amp still has finite output current and bandwidth. Before calling the design finished, run a verification checklist. Check the AC sweep, the gain bandwidth product, slew rate, output swing, noise, and component tolerance. Then inspect whether the response still meets the original specification box. Summary: active filter design is a chain: specification, frequency targets, order, section split, topology, component scaling, and verification. That chain turns frequency response intuition into a buildable circuit. Next, we will change viewpoint and describe circuits as two-port networks using Z and Y parameters.